All right, so I finished my general announcements that included spelling out this week. The only thing on Canvas calendar is the retake for 1.1 is dead tomorrow, so this Tuesday, and then this Friday we're taking the chapter 1 test. Next week we'll start chapter 2. Okay. Today our goal is to get through 1.36. Okay, but before I give you all time to work on some stuff, I want to just comment on some of the resources that are in your packet. So again, these are not problems for you to complete. It's reading for you on your own time. So the first image I created because I wanted to communicate to you all that when you are trying to describe a distribution using the number summaries, you usually have a choice between median and interquartile range or mean and standard deviation. Now, I have no problem, by the way, if you don't want to use interquartile range, you can use standard range, but that's really sensitive to outliers. So the moment you have an outlier, you can't really trust the range anymore. The interquartile range is a little less sensitive, okay, or what we call more resistant. Now, when it comes to these two groupings, you can only choose one or the other. Like if you're trying to describe center and spread, you should either be using median and interquartile range, or you should be using mean and standard deviation. We haven't learned about mean and standard deviation yet. That's going to be a huge part of chapter 2. Okay. And believe me when I tell you, when we get to chapter 2 and we start learning about how to calculate standard deviation and what does standard deviation represent and what the heck are z-scores, I am laying the foundation in a huge way for this class for the rest of the year. I'm not exaggerating when I say that. Okay. In fact, a piece of common feedback I got from students at the end of last year, when a number of students were talking about parts of this class that they enjoyed, one of the things they said was they loved the flow of the class. It was sort of like it made a lot of sense that chapter 7 comes after chapter 6 and that chapter 6 comes after chapter 5. And the concepts really do a good job of building on themselves. Okay. And I'm telling you, when we get to explain standard deviation and what are called z-scores in chapter 2, that is something that's going to follow you for the rest of the year. And if you don't make sense of those concepts, it is going to hurt you for the rest of the year. Now, that being said, I haven't really taught you much about standard deviation yet. So I'm going to keep it very surface level today because that's really a chapter 2 topic. But the bottom line is, as mathematicians or statisticians, we want to be able to use the mean and problem is these values are what is called sensitive. And here's what I mean by that. If you have a data set of 1,000 data points and you change one of them and you change it just a little bit, you will still see the mean and the standard deviation change. Those values will change. Okay. However, the median is a measure of position. So it's not nearly as sensitive. You can have a situation where I'm in the middle 50%. So 50% are under you and 50% are above you. And if any one of those 50% of the points above you change to some other number that's still above you, you don't change. You're still in the middle. Does that make sense? So the median is a good measure of center. And one of the strengths behind it is that it's not sensitive to the data within the data set. A lot of data points can change and the median doesn't go anywhere. So that's kind of a nice thing. It is more consistently representative of the data set, but these values, meaning mean and standard deviation, appear in formulas a lot more, and they're far more useful to a mathematician or statistician. Okay. Now, this is an example of what I mean by unusual features. If you have a data set, a distribution that is normal, that's what I just highlighted. It's a fancy way of saying unimodal and symmetric. So a nice, pretty curve. That's when you can use mean and standard deviation. And believe me when I tell you, nearly any situation in life can be modeled with a normal curve. So while that may seem like a really strict thing, like you can only use mean and standard deviation for a unimodal normal curve, a unimodal symmetric curve, it's actually not a very strong restriction. Okay. Now, if you have bimodal data or multimodal data or skewed data or data with outliers, these are all things that cause the mean and the standard deviation to react in a way that makes them less representative of the data as a whole. And so when those weird things occur, we fall back on the first little peas in the pod group and just say, all right, we're just going to stick with median and interquartile range, or range if it's still appropriate, to be more representative of the data set. Okay. Go ahead and turn the page. Top half is something I've already been barking for the last several classes, so this hopefully is nothing new. If you have a skewed left distribution, you should expect the mean to be less than the median. If you have a skewed right distribution, you expect the mean to be pulled up to the right greater than the median, and symmetric, you kind of expect them to be about the same. Now, before I give you time to work in your groups, I wanted to kind of show you what I meant by the mean and the standard deviation sensitive. Okay, so imagine you have this data set. Looks like it ranges anywhere from 6 to 20. So it's a pretty compact area. It has a range of 14. And let's say, I don't know, that represents scores of some kind. It really doesn't matter. Right now, you have 3 different measures of spread. Again, you don't understand. I haven't taught you standard deviation yet and what it represents, but for now, just know it's a way of measuring variability, how spread out the data is. So you have 3 different measures of spread, and you have 2 different measures of center, okay, the median and the mean. Now imagine I take one of those data points and I change it dramatically. I take that one high data point and I change it from a 20 to an 800. So it's this ridiculous outlier that's out in Pluto somewhere. Notice what that did to these 3 highlighted measures. It has basically destroyed the mean. The average score is not 39.6. Pretty much all of the data is in a much tighter zone of 6 to 20. But suddenly it seems like the average score is nearly 40 because of one data point, okay? And the same thing is happening with standard deviation and with range. Most of the data fits into a range of 6 to 19 or 6 to 20, a range of 14. But suddenly the range is 794 because of 1 point, okay? But notice, while those values were destroyed, the interquartile range and the median remain unmoved. And that's because those are values that are determined by values of position. And what I mean by that is the mean basically didn't do anything. It's still what it was, because all you did was take a high point and make it a higher point, okay? And Q1 and Q3 also didn't move, so the spread between them didn't change, the IQR. This is what we refer to as being resistant. And whether you are changing a data point, and so the median literally doesn't change, or you're adding a new point, which is what I did in the third set. I just said, well, what if we don't change a data point? What if we add a new one? Yeah, the position of the median might change one little spot, but it's essentially the same. Does that make sense? You can have a situation where one new data point causes the median to shift one little spot. So yes, fine. Yes, the median can change, but it's usually pretty resistant. Okay? So to summarize, this is just understanding what I meant by sensitive versus resistant. This is something we've already sort of understood about the relationship of mean and median based on the shape. And then we'll get into it much deeper later on, but you basically have 2 groups of statistics to choose from for center and spread. Okay? All right. So I'm done jabbering. Go ahead and turn to this page. It starts on 1.32. I'm going to give you all 7 minutes to respond to the entire page. Bless you. One thing I'd like to stress, because these questions can feel weird when you read them. I'm not asking you for the right answer. I'm asking you to select the answer that is most likely the right answer. Okay, you can't know the right answer. You can just make educated guesses about the right answer. So keep that mentality when you're working through this. All right, so this is your time to read, think, talk, then write. Go. So I gave students 7 minutes to work on these. I revealed the answers to the first 3 are D, D, and D. We'll get to 1.35, the written one, in just a moment. Okay, with the first one, you're asked which is most likely to be the median. First thing I would do is identify how many data points you're working with. In this case, you're working with 27 data points. So if you have a family of 27 data points, it's an odd number, so one of them can be the exact middle. That leaves 26 other data points, 13 under me, 13 over me. In other words, the median is the 14th data point. Now, whether you decide to count from the bottom up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right there, or you decide to count from the bottom down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is right there. Either way, you end up at the same spot. Now, you should have hopefully identified that the median is in a bin that is marked 20 to not quite 220. If you're 220, you are immediately part of the next bin, okay? So the only answer that I would say is absolutely impossible is E. It cannot be 220, because if it was 220, it wouldn't be in that bin. It would have been next bin, Okay, now of the other four values I want to express to you all, any of them is possible. For all we know, every single data point in that bin is equal to 200. That's just 7 200s over and over again. And so the median is A. This is why I said I'm not asking you for the right answer. I'm asking you for the value that is the most likely answer. Now, within that bin, what we agreed on, if at least if you watched as I illustrated through it, the median is the very, very last data point in that bin. So if you have a bin that ranges from anywhere from 200 to 219, and the median is the very last data point in that bin, it's probably closer to the higher end. Hence, I went with 219. Now, if in counting the digits, the median was right smack in the middle, I probably would have gone with 211. Okay. If the median was the very first data point in that bin, then sure, I'll go with 200 or maybe 203. But at that point, it's not even a fair question. It's like 200, 203 are basically interchangeable. Questions? Okay. Now, for the next question, I will admit, if you weren't able to get the correct answer in 1.32, it kind of makes 1.3 extra challenging, which is why I said, if you're getting stuck, just move on, because you can answer the other two questions without it. Okay. It says, for the histogram above, which of the following is most likely true? Now, first of all, I think we can all agree the data is clearly skewed right. And what that should mean to us is we expect the mean to be greater. So you should immediately eliminate any options that would suggest the mean is less than the median. Okay, just based on shape, B and C make no sense. So really, it's just a matter of, well, where does the mode fit in the median mean world? Well, first of all, I kind of tried to convince you all that we already suspect the median is the very last data point in that bin. We also know the mean has to be greater than that. And what I would say is, when you look at this, you would most likely suspect the mode is somewhere in that bin with 7 data points. Okay, so the mode is somewhere between 200 and 219. Well, given those options, if the mode is somewhere between 200 and 219, and the median is probably 219, and the mean has to be greater, well, then reason would suggest the mode is probably the lowest of the three. Okay. And that's sort of what I explained in my green writing over here. So that's why I went with D. Okay. All right. Now, the next one, this is again skewed right. I would imagine it's because you can visually see the top 50% is clearly more spread out than the bottom 50%. Okay, so that is a box plot telling you the underlying distribution is most likely skewed right. Notice I still say most likely because a box plot is a very shadowy image of the underlying distribution, and I have no idea what the data actually looks like. Okay. Now, I may be stealing some of your answers here, and it's because of a poorly designed question on my part. For question 1.35, I asked, what's wrong with it? If any of you talked about the lack of labels, I agree with you, but the axis isn't even labeled. So it's kind of like there are lots of obvious issues with numbers. So if you said something to the effect of the numbers are missing or the labels are missing, I agree with you. My challenge to you, though, is was anyone able to figure out what else is very clearly wrong with the box plot? The whisker went too far to include outliers. You got it. So let me explain what's going on here. Okay. If you recall, what we said was if you want to determine sort of those invisible interquartile fences, what you have to do is find the interquartile range, but then multiply that by 1.5. So essentially add 50% of it to itself. Does that make sense? You then take that and you either subtract that from Q1. You'll notice that the lower whisker is not outside that box. So the lower outlier or the lower whisker is not an outlier. It's perfectly fine. Or you add it to Q3. Okay. And you can see that the upper whisker is clearly beyond that. So this upper thing should have been marked as an outlier rather than being used as the whisker. Now, I have no idea where the whisker would end. Okay, let's be clear on that. It is a mistake to assume the whisker is going to be right there. There's nothing that says a data point has to exist the imaginary invisible fence. There's nothing that says that. For all we know, other than that one crazy outlier, the very next data point was right there. And so there is no whisker. You see what I'm saying? Like, you have no idea what the underlying data actually looks like. All you can say is, just based on the scale, this is not a properly constructed box plot. Okay? All right. So what did I say? I should have revealed that a long time ago. So I said the maximum is so high, more than Q3 plus 1.5 times the interquartile range, that it is an outlier and should not be used to actually construct whisker. Again, I don't want to discredit anyone who talked about the lack of labels or the lack of numerical labels on the data points themselves. Those absolutely should have been there. And I kind of wrote myself a note to update this display and put numbers in it, just so that people are more prone to catch what I think is the bigger issue, or rather, I should say, the less obvious issue. That's probably a better way of putting it. Questions? All right, so I gave students another 7 minutes to work ahead of me on the next page. One thing I probably could have said at the beginning, this is, again, not made up data. This is actual data from our gas expenses in that year. And I actually think, yeah, it's still more expensive. I know gas went really high at one point, came back down some, but that's still definitely cheaper by far than it is today. In fact, I think right now our distribution is probably centered around $50. It usually costs about $50, rather than around like 35, 36, whatever that is. All right. Let's see, zooming in. So I want to be clear that your numbers may be different than mine. That doesn't make you wrong. For the median, it would be the 36th to 37th data point. Okay, I went with 38, but if you did 36 or 37 or 38, no problem. I'll take that. Okay, to be perfectly clear, okay, and I numbered the individual data points so you could see it way more quickly. Granted, that's probably kind of small for the folks in the second row. You have 72 data points, so that means if you cut it perfectly in half, you got 36 and 36. So where the 36 and 37th data point meet is your median. Now, that's in a bin that apparently goes from 36 to 38, and those are the very, very peak of that bin. So I went with 38. Okay? But again, all you can really know is that it's somewhere in that bin. So 36, 37, 38, perfectly fine. Now, for the next one, this is again where I'm going to have to take two different answers, because it's not so much about what your answer is, but how you decided to justify it. And allow me to explain. What I imagine is most of you probably went with the actual dollar values. And you said, well, if the median is 38, it goes as high as 50 and above, which is basically a spread of 12. It goes as low as 20 or lower, which is 18. So you maybe saw that the top half seems to have a spread from 38 to 50, which is 12, or 38 to 20, which is 18. And so you argued skewed left, and for that reason you said, I expect the mean to be less. If you didn't say it, that doesn't mean you're wrong, so don't start erasing your work, okay? If you said less than because the distribution is skewed left, full credit. But here's the other way some people might look at it. All I know is the median is somewhere in this bin. I don't actually know what the value of it is. And on the right side, I've got 1, 2, 3, 4, 5 bins. On the left side, I've got 1, 2, 3, 4, 5, 6 bins. So yeah, I mean, there's a little bit more spread on the lower side, but let's face it, if you took two little data points and moved them here, just 2 out of 72, well, then it's 5 bins on that side and 5 bins on that side. So it's roughly symmetric. Okay, this is part of the nature that I can't control of real world data. Sometimes it's not clean cut. That won't happen to you on the AP exam. That's all I can promise you. On the AP exam, the examples they throw at you are going to be freaking obvious because they want 200,000 people to have the same opinion. Okay, so they're not going to give you something that's kind of in the tweener zone here. But for this specific example, I would take either answer. If you said about the same because it's roughly symmetric, I'm not going to argue with you. It's close enough. Okay. Now, first quartile, once again, you kind of have to be, you have to be mindful of the fact that there are multiple right answers. When I found quartile 1, I went with $33. When I found quartile 3, I went with $43. But if you had anything for quartile 3 of 42 to 44, 42, 43, 44, I'm fine with that. If you had for quartile 1, 33, 34, 35, I'm fine with that. So my interquartile range may be 10, But if your interquartile range is anywhere from 7, 8, 9, 10, 11, that can be based off of values that are logical. But I'm telling you now, if you got a value outside of any of those regions, it gives me pause of how you decided on that. Okay. Does anyone want me to show how to get Q1 or Q3? Perfect. All right. I'll just go with Q1 for now, but if you want me to do Q3, no problem. So what I did to find Q1 was I said the data can be cut into 36 lower, 36 upper. Q1 is the middle of those lower 36. So now I have to imagine cutting it into 18 and 18. So Q1 is somewhere between the 18th and 19th data point. That occurs right here. Now it's almost in the center of the 33, 34, 35 bin. So again, you could have said 33, 34, or 35. But to me, it was like kind of on the lower end of that bin. So I just went with 33. Okay. But again, you could equally argue 34. Okay. Was that good enough, ladies? All right. All right. So this again would vary depending on what your interquartile range was. For me, I ended up with a lower quartile fence of 18 and an upper quartile fence of 58. Now I want to be clear. We have two values that are less than 20, and we have four values that are greater than 50. So it's possible there are outliers, but I cannot definitively say that. For all I know, those 2 points are $19 and change, and these 4 points are $52 and change. The question is, can you definitively say there are outliers? Now, some of you might have ended up with an upper quartile fence of like $21 and change or something like that. Well, then fine. Now you can say there are definitive outliers. You know those are less than $21. Okay, so again, obnoxiously, part D varies based on what numbers you went with. Okay. The final display is just because I'm a nerd and I find it fascinating that I discovered that we spend more on gas in the summer months. And that's something with this time plot you can see, but you never would have seen that in the histogram. And that's another kind of twisted way they like to ask questions sometimes on the AP exam. They'll give you the same data in two displays and ask you to discuss what can you see in this display that you can't see in that display. That's kind of a question that comes up, pretty consistently. All right, sorry to go right to the bell, folks, but those that are watching, thanks for watching. We're done. Have a good day.